So here we are, 3.2b, and we're going to continue on with what we did for the first example, and nothing really changes. It doesn't really get any harder. It just gets maybe a little bit different, but even different isn't necessarily bad here. So they're giving us something like this. And one thing to notice here, when you're given four terms, usually that gives you a clue that you're going to be doing some grouping. All right, so the first thing we're going to do is we're going to look at our leading term there. It's positive, and our exponent is 3. So it's going to give us a graph from page 258 that's going to look like that. Okay. Now again, I don't know what's going on in here, but I will tell you that actually the graph is going to look like that. Okay, when it's all said and done. So yeah, we've got between here and here, we've got stuff that goes on. Alright, so I know that's what it's going to look like. And let's see, let's go ahead and find the zeros. So to find the zeros, remember we put 0 in here. We're going to group here. We're going to factor out an x squared, leaving me a 2x plus 1. And then here we're going to factor out a 4. So that's going to give me a 2x plus 1. And notice that and that are the same. And again, remember when you factor out that 4, that negative has got to change to a positive so that when we put it back in, it gives me my negative 4 back. So just some things to focus on as you're doing this. Giving me 0 equals x squared minus 4 times 2x plus 1. And then again, we have to make it into linear factors. Can't have any exponents on our final answer. Okay, so what does that tell me? 3 answers, 3 up there. So my answers are going to be negative 2, 2, and negative 1/2. So my x, or my x-intercepts are going to be at negative 2, 0, 2, 0, and negative 1/2, 0. Okay, that's where it's going to cross. Alright, so just again, if it helps you to have kind of a graph here, at negative 2, 0, at 2, 0, and negative 1/2, 0. Okay, those are where they're crossing. Now look what we have here. We have an interval here, we have an interval here, one here, and one this way. Okay? So, and it also is, because this is a 3, remember 3 minus 1, or whatever number this is minus 1, gives you the number of maximum turning points. Alright, so this interval, this interval, this interval, and this interval. So let's see what happens at each of these 4 intervals. Alright, so let's go ahead and draw our table again. I'm going to move all this stuff up. We really don't need all this stuff. Whoops. Anymore. Let's move that up. And so my intervals are going to be, well, let's get this back down here again. Come on. Alright, so my intervals are going to be negative infinity to negative 2. That takes care of everything over here. And then we go negative 2 to negative 1/2, and that takes everything from here to here. Then we go from negative 1/2 to 2, and that takes care of this, and then 2 to positive infinity. And it should be pretty easy to look at this, because the last number here will be the first number here. Last number here, first number. Last number, first number. Okay, so it kind of helps you to get that down. Alright, so we're going to use some different x values here, because we want to see, again, if in this interval the graph is below the y-axis or above. Again, I don't care what the y value is, I just want to know if the y value is positive or negative. So we put in, let's do this in blue, negative 3. a number that fits somewhere in there. And when I do that, it spits out a y, or an f of x, of negative 25. So this is all I care about. So I'll just put sine. Sine is negative. And for this one here, I'm going to put in something between negative 1/2 and negative 2. So an easy one would be negative 1. Spits out a positive 3. So it's positive. And for this one, somewhere between negative 1/2 and 2, let's use 1. Spits out a negative 9, so it's negative. Okay, so again, if you can figure out that this answer for y is negative without doing all the math, if you can just look up here at the original problem, stick in a 1 and go, oh yeah, it's going to be negative, just put a negative there. You don't have to find the answer. All right. Except it does do nice when you're trying to graph this to give you some points to look at, but other than that. Alright, so between 2 and infinity we're going to put a 3, and oh crud, gives me a 35, but it's positive, and again that's the number I'm interested in, is it positive or negative. Alright, so we have all that. So let's use those as our test values. We're going to use, we have our test values, and if we can graph these, it's just kind of saving us a little bit of time. I mean, the negative 25 and the 335 can't really graph that. They're too big, but at least we can put some of this stuff on the graph here. All right, so let's see. Let's go ahead and move all this up so we can graph, get a lot of this junk out of the way here. Okay, except those points there. So I've got my graph, and let's see, I know that one of my points is negative 3, negative 25. So let's put this as negative 3, and my negative 25 is going to be way, way down there somewhere, so we can't really graph that. But I can graph negative 1, 3, and 4, 5, 6, 7, 8, 9. I can graph 1, negative 9. I get something down here. And then 3, 35. 1, 2, 3 is going to be way up here somewhere. Okay, so my negative positive will be here, negative here, and then we go back to positive there. All right, so the degree of this thing is, what did we say it was? The degree is 3. So the graph can have at most 3 x-intercepts and at most 2 turning points. And when we start plugging stuff in, we're going to get a graph that kind of looks like, let's see, goes through negative 2 up to here, and it's going to turn and cross again at negative 1/2. And oh, we didn't find the y-intercept. We can do that in just a sec. It's going to turn here, and then it's going to go up through, I guess this is 2 right there, and look like that, which is very similar to what step 1 said it was going to look like. But let's go ahead and look at the y-intercept. Y-intercept means, remember, we put 0 in for our x. So when we put 0 in for our x, we get 2 times 0 cubed plus 0 squared minus 8 times 0 minus 4 equals negative 4. So that is my y-intercept, and that's where it crosses, 1, 2, 3, right there at negative 4. So we've got, our first interval that goes up through negative 2. So there's a crossing. Negative 1/2 is a crossing, and then positive 2 was a crossing. So what I was interested in finding out by plugging numbers in is what it does here and what it does here, because I know what it does here and here at the ends. Because remember, when we did this, we had something like that where we did know what was going on there. So what's going on there is this whole thing goes up and then down and then up again. And that's what we are looking at doing. So in this next example, example 3, that one is pretty tough to go ahead and factor. There are 5 terms there, and that's a little bit difficult. The next 2 lessons, 3.3 and 3.4, we're going to learn how to determine the factors of polynomials that are massive like that. But for this one, they're going ahead and just giving you what the factored part is. And so we'll do that example, and example 4, which is another part that we're going to do, you'll find that isn't too terribly difficult. So I'm going to stop the video here because I'm at 11 minutes, and we'll do example 3 and the intermediate value theorem on the next video, but it shouldn't take too terribly long.